Okay, I need some help. So here's the thing. So remember, you guys used to tell me that there are so many errors that have happened here and there with Schoology or Google Forms or specifically. Yeah, I want to you guys to remind me all those emails which you had sent me, send them again today because they're buried deep in my TLC account. I tried to look them, so I tried to pull some of them up. I could correct some of your marks. So if there is any marks things that have to be changed. So what happened was you must have received your two examination marks today. That is one is this thing. There's a test. I have no idea. Okay, listen, you must have received the marks of your electromagnetism exam as well as the magnetism exam. Remember, there was a topic like that, it's called electromagnetism. Yeah, that thing, exactly. So that thing, yeah, please go through it. So if you are okay, I know, Shashank, about that. You had an issue which was out of 50 or 43, so the test was out of 43. So I'll be rectifying that. I have some difficulty rectifying Schoology errors. Google Classroom is fine, I can solve them. Schoology is annoying, I can't edit your marks, I'm trying. I tried reading Anita's that answer. I could not. I struggled for half an hour. Now I'm thinking of overriding using some other methods. Let's see what happens. You should gives, but which one? Which one is this? That's what I want to be reminded. So your marks have been released. Those are not the final marks which have been released. Okay, I'll be changing them. I want you guys to tell me now what things have to be changed. I know. You have to leave me an email regarding everything, whichever that is. It's about the human eye? Which one is it? Please leave me an email right now during the next over the course of next 2 hours, okay, about the errors. I think, Anvita, your issue has been fixed, both of them, the except the Schoology one, that can't be solved. That I'll look into it. It's going to take time. You're going to have a hard time this week? No, I'm trying to finish it by tonight. So that's one thing. I'm trying to resolve that by tonight. Anyways, please mail it by today. It's happening today or it's not happening. That's all. So that's it. Uh, what due time? Please send it by 5:30. That's all. If there has been an error, check all the messages you have sent me, all the rubbish emails you guys have sent me. That's all. Okay, just scroll through. You will find something. Okay, whatever doubts you made me, whatever there was an issue with the marks here, issue with the marks there. Yeah, you guys used to mail me, right? Mail it once again. I am scared for my inbox, but anyways, let's just take a risk here. Just send me, and if anybody plays a prank, punch you in the face. Okay. Anyways, what about coding classes? That's a problem for next Saturday. I am sleeping till then. Echo about it. Okay, chill. Don't worry. We'll look into it. There's going to be something. I'm having some meetings, discussions. We're working with it. So I'll let you know. Yeah, I have 9408 emails. Yeah, digging in that is like digging through, I don't know, the worst metaphor you can find with sand and beach. Okay, it's that. So, oh, no, we're not talking about the assignments or coding sessions. Those are separate. Forget about them. I just care about your physics part, that too. Not even the math part right now, only the physics part particularly. Okay. Yeah, finding a needle in a haystack. Thank you. Yeah, make a new email account. No, I'm not doing that. I'm not stupid. Yeah, Amit, I'll let you know. Yeah. So the thing is, I won't check. You are, it seems. Okay, yeah, I'm stupid. I agree with that part, but I'm not making a new account. Fine. Okay. We'll go ahead 1 second. So please, yeah, did as you told. Thank you for the email. I received it. Others also keep sending emails. Yeah, I know if I do that, look, Anyways, check it. Pratish has 8 email IDs, it seems. Bomber emails. See what is the fee for the coding class? Okay. Control, Prajwal, control. You've controlled before, you can. Come on, sweetheart, you can control. What to send an email if there has been an issue. Oh, by the way, do not, okay, send it to my TLC account, anything is fine. Preferably send it to my account, okay? But don't send it in two places. I don't read twice, okay? First of all, okay. Which fee? There is no fee, dude. Oh God. Yeah. Okay. Let's continue with what we are doing next. Last class. 1 second. Where is that thing? Yeah. Yeah, this is what happens when you have 8 to 9 email and this each of 100. No, not that point. The point is I don't check my this thing. I think the only time an amazing thing happened with my email account was it got hacked by a student, probably 6-7 months ago, where my profile picture was changed to Donald Trump's picture, which I could not change back. Okay, and it was not just Donald Trump, it was a mixed morph picture of Kim Jong-un and this guy's picture. It was awesome. There was only one student who was capable of doing that, achieving that. She's in Bangalore. I recently spoke to her. Apparently she didn't do it, so it's fine. I'm starting to think, yeah, she was capable of doing it, at least that awesomely, without getting caught. But anyways, yeah, anyways, that was fine. That was one. I know I gave you guys a lot of ideas to the hackers and coder community in the class. Don't do that. Okay. Yeah, no, Amit, no. Anyways, so the thing is, did anybody solve this? Come on, tell me. Did we get an idea how to solve it or solved it? Okay, fine. You guys sent me the email. Those will be rectified. I'll try to dig, but it is recommended that you guys send me the emails of any issues. Okay, I didn't give it a thought. Expected that. What else, guys? Hey, who solved it in class? None of you solved it. I want the solution, not the answer. I think one person did. 1 or 2 people did. Answer anybody can give. There is Desmos. What is the answer then? Okay, what is the solution? Sorry. What is the solution? I don't care about the answer. Answer was 7, guys, for this. A1 plus A2 plus A3 plus A4 was the answer. Amit got it right. Yeah. Oh my God. Yeah, Murali gave. I knew. I looked at your face. It didn't look like you gave the answer. So I then again asked the question again. Anyways, Shashank says it is 7.0001. Maybe. I don't know. Keaton, yeah, that makes sense. Okay, Keaton also got it. Anyways, the answer for this is super easy. 7. The reason why, yeah, you got 6.9 and fine. Amit. Mithul also. Yeah, I'll tell you why. What's the solution? How to solve this? It's very easy. Do you guys know the fact? Yeah, solve the equation by equating it to 10. Possibly. The idea is that's what. Maybe that's the method. I hate rain. Okay. So. Oh my God. Okay. If my voice got louder, sorry. Let's say you have an equation xa square. Oh, thank God. Okay, x square ax square plus bx plus c is equal to 0. What is the sum of the roots of a quadratic equation? Tell me. Tell me. What is the sum of the roots? It's given by minus b by a, right? It's minus b by a. Turns out this thing holds good for even higher order equations. Like for example, if you have a cube plus bx square plus cx. Yeah, I know, maybe. How do you know Mr. voice? Okay, yeah, give you the number. D is equal to 0. Then still the answer is still minus b by a, the sum of the roots. If there are 3 roots, a plus b plus c,
let's say r plus m plus n plus, I don't know, p plus q plus r. That goes well. So if you have three roots, p plus q plus r, then the root answer is still minus b by a. Doesn't matter what the order of the equation is, it's always true, it's been known. Is it fine? And the product is given by c by a always. Not c by a, the last coefficient, d by a, last coefficient, d by a. Fine with this? D by a, the last coefficient, the product of the roots. So sum of the roots is given always by, okay, a cubic equation, how many roots does it have? Tell me, at least you tell me that. I think you're suffering from cold. It could be worse than that, given the situation of lockdown.
Dry cough, headache.
I went to CFL, shouldn't have today gone in the morning. Doesn't seem like a good idea. Marja Sale, it seems.
Picked up the fried rice.
Yeah. No. It's just lying there probably. I don't know. Your voice has changed completely. That is because of I'm keeping the microphone close. Now, is it better? Is it fine?
You were sounding 35 years younger.
You know that go negative, right? In my case, I'll be dead. Like, I don't know. It's pre-birth.
Really?
Yeah. Anyways, a cubic equation will have three roots, right? So the p plus q plus r will give you minus b by a. P into q into r will give you what? D by a. Is this fine? For a cubic case. For a quartic case, for the fourth order, this equation is still true. No, it's d by a, I think. Is it minus d by a? Yeah, it's minus d by a. Maybe. I must have gotten it wrong. It could be minus d by a. There's a chance. Okay. Now, with that being said, listen to this part. Now, I have a question for you. So if you have this equation here, listen. And let's say you have a line y is equal to 10. Fine with this? You have a line y is equal to 10. Okay. So watch me play the game here now. So let's say I have Desmos and I have, listen to this. What's the equation? Does anybody remember the equation? 3 minus 21, 7, 13. 3 minus 21. Okay. 3 minus 21, 7 plus 7x square plus 13x plus 10. Okay, so if you look at the graph now, look at this. Can't hear my voice. Listen. Can you see this? So if you look at this equation, can you see it's a very complicated looking graph? Y is equal to, yeah. But then if I have y is equal to 10, it'll cut it nicely at 4 points. You guys must have tried this. Is it fine? Can I get a yes on this? Clear? Yeah. Now, the thing is, if I were to, what do these points mean? Tell me, these 4 points, how do you get these points? Tell me. How do you get these points? How do you solve two lines and get a point? Tell me. Like, if you have two equations, y is equal to mx plus n, another one, simultaneous solutions, right? You solve them simultaneously. Agree with me? Yeah, I get you right. I'll come to that, Keaton. I'll come to that. Do you agree with that? Yeah. So the thing is, do you agree that these two are simultaneous equation, y is equal to 10 and y is equal to 3x square plus this thing? Both are simultaneous. Yeah, only problem is they are not your linear equations anymore. They're complicated. They're simultaneous, but okay. Now, how to solve an equation? Tell me. How to solve simultaneous equations? One method is to substitute, right? Substitute y is equal to 10 in the previous equation. Agree with me on this? Yeah, that will give us, what does it give us? Yeah, substitute. So what I'll do is I'll substitute this. 1 second. I'll substitute it here is equal to 10. Fine with this? I equated it to 10. But if I cancel 10 on both sides, I get a simpler equation is equal to 0. Got this part? I have a quartic equation now. Yeah. Now, if I solve this equation, do you agree I'll get all the 4 points, all the x coordinates? Do you agree I'll get all the x coordinates of this, solutions of this? Yeah, but the problem is, the advantage is I don't have to solve them. I just need the sum, right? I just require the sum of the x coordinates, x a1 plus a2 plus a3, a4. But I told you that the sum of the coordinates is nothing but minus b by a. What is minus b by a here in the equation? Minus 21 by 3. That's what gives you 7. You didn't have to struggle at all. Okay, this was a level 1 Putnam problem. It is easy. You need to have some additional knowledge, but it's not easy. I mean, on the Putnam scale, yeah, not so easy. But if you're writing a Putnam exam, this would be the easiest of the Putnam problems. Tell how it works for any line. It works for any line that cuts. I told you, right? Because of this property. Because of this property. The proof I showed you, okay, it works for any line. Try y is equal to, okay, somebody, one second, I'll try the solution for any line. Take it for y is equal to mx plus c. Do you agree with me on this? Y is equal to mx plus c is another line. Okay, I'll just subtract both the equations. What will I get? If I subtract the top equation and the bottom equation, what will I get? Tell me. If I subtract both of them, y and y gets cancelled. You get 0 on the other side. Now, c will subtract from 10. Agree with me? C will subtract from 10 minus C. 10 minus C. Hope you're fine with that. C will subtract from 10 when you subtract. And 13 gets subtracted from M. So you get 13 minus M, grouping the x terms. But still, even after this, even after doing this, if you see carefully, the coefficients 21 and 3 are not affected at all. Can you see that? The coefficients 13 and 10 are still not affected. Any line you do it for. Okay, so this works. So this works irrespective of what. So this is general. It's not a Putnam. It's an entry-level Putnam problem. Okay, as an exercise, it was given. Yeah. So, anyways, it would be in the A1 scale. Okay. Anyways, have you guys studied this? Tell me. I know it's a joke. I know it's a joke. I mean, like, if your eyes start bleeding, look away. Yeah, I won't breathe into the mic. Sorry, I am not. Why are you blowing? That's blowing air, guys. Okay. Yeah, I am not. Okay. I need to wear a mask, guys. That's the only way, because the microphone is. Yeah. Oh God. Okay, there's water there.
Or you can swallow the microphone.
Oh, that has happened in one class, almost. Like, you know, I wear that mic, right? One second, I was keeping the microphone very close, that's why. Okay, that is water. Thank you. By the way, there was a compliment for the organic chemists in the class. Organic chemists are surely creative, it seems. Anyways, what are the symptoms of corona? Go to the hospital. Use. Yeah, I know. Murali was actually planning on calling the corona helpline so that there's no class. He was actually considering it. I mean, like, I don't know whether he called or something like that. I don't know. Anyways, earlier. Anyways, with that being said, you guys know this, everybody. If you want a record, give it as a proof. There's a cough. Yeah, you guys know this, right? Yeah, you guys know that I don't have to. Yeah. Now, based on that, solve this problem. Is this possible? Is this situation possible? Determine the present ages. The sum of the ages of two friends is 20. Try guessing. First solution is guessing. 4 years ago, the product of the ages was 48. Is this possible or not? How do you say no like that? Have you seen this problem before? Guessing? Okay, I didn't mean guess like that. I told you to try some years, guys, which would work. Not the yes or no guess. I don't care. Try some values, I said. I mean, what if the age of the friends is 10 and 10? Does it work? 10 and 10? The product won't be 4 years ago. What will be the product? Tell me. If it's 10 and 10, it gives you 20. But the problem, one second, 10 and 10, 1 second. 4 years ago, what will the age be? 6 and 6, right? Yeah, 6 into 6, does it give us 36, 38? What do you say? 48? No, it doesn't work. It gives us 36. So that can't be possible. So 10 and 10 is not possible. Which are the other values? 10 and 10 is ruled out. 1 and 19. Okay, 1 and 19. Then, 4 years ago, that guy is not even born. 1 and 19 is not possible. At least start with 4, so that it's a baby. Present age, it's a baby. Your friend with a baby at least. 0, Is this a Diophantine problem? No, not exactly. Yeah, this problem is a typical one. Yes, Navya. Yeah. 4 and 16. Let's give it a shot. 4 and 16. Then there's a problem. The product will be 0 into 12. 4 is equal, this guy was a baby. It's 0, giving us 0. Not so soon. Yeah, Sakshi, yeah, that's correct. But the question is, how do you solve it generally? Do you agree x plus, let the ages be x plus y. X plus y is 20. Then x minus 4 into y minus 4 is how much? 48. Agree with me on this? Fine with this? If you're solving it, is everybody comfortable with the equations, what I wrote down? Let the ages be x and y. Y just like that. Is this fine? Yeah. Now, if I multiply, before multiplying it out, I'll do a substitution. I know that y is equal to 20 minus x. Okay, y is equal to 20 minus x. So what I could do is, if I substitute it here, I'll get in the other equation. I'm trying to solve both the equations simultaneously, right? Both of them. So if I plug it back in here, I'll get x minus 4 into 20 minus x minus 4 is equal to 48. This will give us, if I'm not wrong, x minus 4 into 16 minus x. Oh my God. How did I say 16 and write 14? Anyway, 16 minus x is equal to 48. Multiply it out, you get, I think, 16x minus x square minus 64. Yeah. Then what? Plus 4x, yeah, is equal to 48. First multiply, then you can substitute. Oh, if you substitute, that's a nightmare. There'll be a lot of y terms jumping around, and that'd be a nightmare, I thought. So I just thought, why not? Okay, anyways, so what does this give us? Minus x square. 48 minus, what does this add up to? Can anyone help me with this? I mean, you don't have to, but anyways, your call. 16x, 112, thank you, yeah. That's going to be minus 112. Oh, by the way, 16x and 4x will give 20x. Yeah, and 112 is equal to 0. Is this fine? B square minus 4ac gives you how much? Tell me. 400. B square is 400 minus 4 times a into c. What is that? Yeah, 112 into, did I miss something here? Yeah, that's fine. Same thing. 4 into 112 gives you some number greater, right? Agree with me on this? 4 into 112 is how much? 448, right? If I'm not wrong. Yeah, that makes a discriminant greater than 0. So b square minus 4ac will be magically done. Substituting x plus y in the equation, you get xy is equal to this. Yeah, that also would work. But the idea is they want to go with the discriminant method. You can go with that method also. That would work, Shashank. Yeah. Oh, I asked you guys a question last year, right? None of you answered me this. I don't know. I asked you this. How many times does the Earth go? How many times does the Earth revolve in a 365-day journey? That was a question I asked. Something like that. Yeah, something similar to that. I mean, rotate on its axis. Rotate on its axis in a 365-day cycle. Year cycle. In a year. Is it 365 or if it's a 365 days thing, how many times? You got to think carefully about this, okay? This is a tricky problem, let's say. I mean, it's less than 0. Sorry, less than, I'm sorry about this. I kind of messed it up. Less than 0, yeah. Less than 0, thank you. Okay. So b square minus a, you get an imaginary number, yes. 350-ish. Ish is a word for plus or minus, dude, for me. That's the word I use. This thing, b square minus 4ac. From this equation, if you look at this equation, I think I need to switch to better colors. 1 second. I need to stop the bloodshed. Wait. Yeah, this looks good. So you have this equation, right? Yeah. Now the thing is, this gives us, what is it? This gives us b square, that is 20 square, minus 4 times a into c, but a is minus 1, 112 again. So that gives us 448. I told you, right? Wait, I got it. 4ac, multiply the coefficient. This is a square, ax square plus bx plus c is equal to 0. Okay, awesome. Since everybody's got it, hopefully everybody got that. Okay. Now, going ahead, I have a question for you. Lateral lump. Yeah. A farmer wants to construct a fence for a rectangular field. These are common problems with joining a river. Okay, he has a problem. So he contacts an engineer. That's the backstory. He has 40 meters of fence. Okay. What should the dimensions of the rectangular field be if the area of the field should be maximum? By the way, the fence is only on this side, like here. He can make the fence very steep like this, like very, very less small like this. Or he can make it very, what do you say, whatever its call is. But the yellow color thing is a fence. Why can't you imagine ages? No, I don't know. So you're insulting that we are engineers. Oh, no, I'm not calling you guys. He just contacts engineers, I said. Usually this is engineering job. There's this set of things you get after getting into science after a few years. I think a farmer, it's a joke, but you may not laugh at it, you may not get it, but this is how it goes. It's an anecdote kind of thing. A farmer once had a fence, and he wanted to construct the largest, he wanted the field to have the largest area. So there's a fence. Okay, like what? I didn't get that. Have I said it? Am I ready? No. Okay. I don't know. So the question is, he wanted to construct the fence that gives the largest area. So he contacts a physicist, an engineer, and a mathematician. Don't know why, but he consults them. And it so happens that the engineer comes along and says, oh, take the fence and put it as a circle. You know, you'll get the largest area possible. If you make a square out of it, it'll consume more this thing. Cow one, I'll say you. Cow one is different one. Yeah, I know. That's a different one. That's a joke on physicists, particularly. Okay. So next he asks the physicist, what should I do? So the physicist says, you take the earth, put the entire rope across the equator. Okay, that way you have the entire field. That's the largest field you can have, that the entire earth that you can get. Okay, that was like an extreme. Next he asks a mathematician. The mathematician will be like, he's like, I'll put the rope around, takes the rope and puts it around himself. And then he says, I consider myself to be on the outside. I assume that I am on the outside. So the entire universe is now the field. That's the largest area you can get. Yeah, you get the point. You guys get the point. So that's a bunch of, topology stuff, I know. So anyways, there is the other one, cow one. That's a very famous one. It's called cows in, what is that? Spherical cows. It's called spherical cow thing. You need to Google it. It's there. It's very famous. It's a joke on physics.
Spherical cows and vacuum.
Spherical cows in vacuum. Yeah, spherical cows in vacuum. Yeah, tell me guys, what do you think is the fence area? What is the largest fence area? What should be the dimensions? Okay, let's try. Let's give 10 meters here. Let's give, let's give us 2 meters here. Let's give 2 meters here. And let's give here, how much is left? 36. Will this give us the largest area? Is this possible? Is this the best you can do? What's the area now? 36 into 2, how much is it? 72. Yeah, 72 meters square. Can we do better? One suggestion was to give, it should be rectangular. The rule is it should be a rectangular field. It's a famous problem. These problems are very famous. Do not use calculus. I told you, right? Calculus is for losers. Okay, go ahead. That's the rule. These only problems are solved using calculus, but I'm asking you not to use calculus. 20 into 20, how will you do that? You can't have 20 into 20, you can't. 20, if I use 20 meters, what will I put on this side? Fence is taken, 40 meters covered already. tell me. 34 into 3. Okay, let's try 34 into 3 in 3. 3 and 3. That should work. Let's see. How much is that? 34 into 3. Come on. 90, 112. Yeah. 112. Does that work? 112 or 102? Oh, yeah. It's 102. Can we do better? Can you guys do better? Come on. The farmer needs help. Keaton suggests 20 here and 10 here and 10 here. You guys think this is better? Let's try. 20 into 20 works. 20 into 10 gives you how much? 200. Okay, can we do better than 200? Can you guys do better? 20, 10, 10 is one option. Can you do better? 36 to 2 we tried. We got 72 meters, that's it. 32, 4, 4 will give you, count it, 32 into 4. Meter square, oh my God. Yeah, guys. Yeah, Murali, fine. Others, think, figure out which do you think is the highest you can do, better you can do. Yeah, Shashank also said it. Shashank MN also, fine. What about the rest? Can you guys do better? Varun, how much you're suggesting? Oh, 3. Red square. Okay, one suggestion that came is 40 by 3 everywhere. 40 by 3, 40 by 3, 40 by 3. Is this better? That'll give us 200. Sorry, 40 into 40 is 1600 divided by 9. Is this better? Now this is less. Even if this was 10, even if this was 10, let's say, no, sorry, 9. Even if this was 200, let's say make this 10, and even if I make this 2000, I'll get 200. So 40 and 10, not so much. 1600. This will give you 160 roughly, maximum. Around 160, 169. I don't know how much is this, 1600 divided by 9. But 40 by 3 will give a square. Yeah, Murali, I'm getting there. That's where I was getting at. 16, 12, 12. That would work. 16, 12, 12 is, yeah, 24. Yeah, let's see. 16 into 12 is how much? 16 into 12. 192. Okay, 192. Now, not 200 still. 200 is the leading candidate. Can you guys do better? 15, 15, 10. 15 into 10 is 150. That's still less than 200. Yeah. 3. Okay, guys. What else? 21, 10, 9. You're changing the shape of the rectangle. No, I'm seeing all the messages. Wait. 20 everywhere is not possible. I told you, right? 20 everywhere is not possible. Because you won't have fence only. That was suggested, right, earlier. It is 60 meters fence. Only 40 meters of fence is available. You can't go greater than that. If you take up 20 here, if you take up 20 here, third one, you won't get the gap. Yeah. That's because of the stupid assignment I gave. And Wikipedia name page was created in my name. 39 and 1. You can't change dimensions like that. 30 and 9. How will you do it? 30 plus 9 plus 9. No, it's not possible. Okay, guys, do you guys agree 200 is the maximum if you're computed so far? Yeah. Now, how to figure it out? Yeah. Keaton told it, Shashank Gemen told, some of you told it. Now, how to prove that? Okay, from experience, you know, this is one of the methods to solve it. The solution is, how it follows, is you call this, what's the solution, Keaton, you tried? Geometric? Yours is a geometric solution, I guess. But anyways, we'll go with this. Oh, 20 into 20, no, that's wrong. 20 into 20 is wrong. 200 is the correct solution. That's wrong. So anyways, listen to this. So let's call this X. I don't want this as X. Is it fine? Yeah, I'll call this X and Y. Okay. this thing x, this as y. Now a question, try that, it won't work. So if you have such a situation, do you agree x plus y is equal to 40? Yeah, or I'm doing it slowly, dramatically with x plus, but anyways, you get the point. That is one thing. And another thing is x into y is, we need to maximize. This gives us the area. Agree with me? Area is x into y. Can I get a yes or no on this? Clear? Yeah, so 2x plus y is equal to 40. So that should be clear. Hope everybody's clear with that. Okay. Now the thing is, if I substitute this y here, I'll get, listen to this, I can substitute y from this equation. I can get y is equal to 40 minus 2x. So if I plug that back in here, I'll get x into 40 minus 2x is equal to area. Agree with me on this? So as I change the area, as I change the x, I get new areas. Agree with me on this? Fine with this? So if I plug in x is equal to 1, what will I get? Tell me. If I plug in x is equal to 1, if I make x is equal to 1, it immediately sets the y. Got the logic? It immediately sets the y also. Y will be immediately 40 minus 2 into x. That gives us 19 into 10.5. Try it. 19 into 10.195 roughly. Right? Still not 200. Doesn't beat 200. Still no. Nah. It doesn't beat it. Okay. So once you got this equation, you know it's 40x square, x minus 2x square is equal to the area. Agree with me? This is the area equation. Yeah. Fine with this? Yeah. We want the largest area possible. So the question is, we're asking, where does area become the maximum? Now, if you had the privilege of Desmos, and if you plot it, this is what the equation would look like. Can you guys see it? 1 second. What is the equation? 40x square. No, 40x minus 2x square was the graph. Agree with me on this? Can I get a yes or no? Is that clear? Can you see that's a parabola? Where does it peak? At x is equal to 10. When x is 10, so y becomes 20. So the entire area becomes 200. Now, how do we find that? You know its roots. Extreme conditions. Not even the roots. Those are the extreme conditions. That's the worst thing you can do with the problem. I told you how to calculate the midpoint. Remember I told you how to calculate the midpoint? Yeah, you don't have to struggle much. If you get the midpoint is 10, right? Agree with me on this? The midpoint is 10. No, it's correct. That's correct. It's x square. Yeah, so that gives you this thing, solution. Okay, the key to finding the solution is to use calculus. One method is to use calculus. You're crazy. But another way of dealing with this is d is equal to minus b by a. Why is that? Okay. That's one more way of looking at the quadratic equation. My point is, if you don't have Desmos, you will have to resort to finding out using with the midpoint using some other methods, minus b by 2a. That's the same one, Minihad. I shared it with you. Yeah. Okay. So did you guys get it? How to solve these problems? These are optimizing problems. This is not necessarily the method, but the idea is the peak happens at the peak of the parabola. So it's exactly the midpoint. So if this was 40 or any other answers, you should be able to do it. Yeah, the calculus method is to take derivatives, which I won't teach now. That's a volume 2 thing in physics. I won't teach it here. Okay. Midpoint here is 10. The extreme point is 20. The roots of this equation are 20 and 0. So the midpoint is somewhere at 10. Peak happens at the peak of the... Okay, I said that, I remember. Okay, now what I meant is the maximum is found at 10. That's what I meant. Okay, anyways, volume 2, yeah, there's a bit of calculus I need. So yeah, anyways. So yeah, I think we spoke about things.
You are even coming for volume 2, is it?
No, I don't think so. Anyways, but let's see. I've told them, but let's see. But minus b by 2 gives you, no, 2a, x square has a 2 in it. 2a minus b by 2a is the midpoint. So the two thing there. Okay, anyways, I received a lot of messages. So till then, 1 second, I'll be doing a switch now to a different chapter. We are done. You will have a, what? That is a chapter that was done. Quadratic equations is done. That was an advanced problem. You'll have a DPP. You won't have a DPP. This is the only PPT with the thank you slide. I was never going to the thank you slide. I was closing the PPT before I went there every single time because I didn't feel like saying it. Maybe I don't know. Anyways, do we have a quiz? Yes, you have a quiz.
I know
Is
people
this
feel
one-
more gratitude towards others during their last moments of their life.
I want water. You know, there's a possibility I could really die. You know that, right? From corona, apparently. Yeah. Anyways, that marriage. Dude, I don't care about the marriage. First, live, no. Be alive to get married. You can't marry a dead body. Yeah. Anyways, I just need to get some sleep. I woke up at 9 o'clock. Shouldn't have to go to CFA. For sleeping at 3 in the morning or something, you should wake up at least at 11 or something somehow. That was the biggest mistake. Anyways,
Who cares? Why are you saying about your problems to us?
yeah, I know. I know. Why did you go to CFL? Nothing. It's just a ignorance thing. Anyways, your generation should continue and should marry. Okay. Anyways. No, not from the filter, from the pot only. Which chapter is volume 2? There is calculus. There isn't calculus, but I teach calculus because I'm crazy. Okay, for the mechanics part. Otherwise, it's hard to go through David Morin textbook and survive that without proper calculus. So yeah, I have no idea, Nidhi. Who I said that? Yeah. Anyways, 1 second. We'll start with a new topic. So I won't tell you what the new topic is, of course, just like always. But it's definitely not about cricket. I'll show you that. Okay, so coming to the next topic. Why is there a bar at the corner? I don't know. Anyways, yeah, Anvita, I know. That's good. That's great. So did you guys send me all your problems? Like yeah, please mail it to me. Do not forget that. We'll start with some problems. I have given this last year maybe, or yeah. Oh, fun fact, this happened yesterday. 3 Blonde released a new video. Check it out. I'm not getting paid for this. Just saying. Okay, please check it out. Yeah, I know. I'm just waiting. Anyways, he's gonna fire. Today's MS Dhoni's birthday. It's awesome. Nice. Good. What? Check the video on your own. It's on something called graph coloring. It's an interesting problem. We'll come to it someday. Okay. Remember this thing, which is a shoelace formula. Do you remember the shoelace formula I taught you? The problem that gives you the area of anything, any random thing, as counterpart to what is that? Hey, remember the shoelace formula when calculating the area of the triangle? Oh, I think some of you are absent. Ancha. Okay, so there is a version of this called the Pick's theorem. Okay, you guys have to check this out also. It's called both. Check both shoelace and Pick's formula. Okay, both are awesome. There's one more thing. But information is just about as 6 words. How? Did you watch the video saying that? That's why you're saying it. Okay. That's because the information is not stored in what is that? The 6 coins. It's stored in the strategy. I think in that problem, if I'm not wrong. I've not watched the whole video. I think so. That's the solution to the problem. It speaks about some Hamming code, right? If I'm not wrong. Yeah, from information theory. Just look into it. I'm not sure. I'll get back to you. Okay, I need to watch the whole video. Then I'll get back to you. Is this number file? No, this is the PBS Infinite series. I recommended this long back. Yeah, Keithan, I will. I came across this in oh, how many of you read Ian Stewart's book? Glad you read it. Somebody brought that up. Okay, by the way, two shows I recommend. One, first things first, I recommend two series for you guys to watch. First one is called Numbers, NUMB, MB. Oh my God, MB. Muralidhar has ruined my life. I can't even write M. NUMB 3RS. It's a show. It's a television show. 6 seasons. Amazing stuff. Detective stuff. Yeah, yeah. So it's on mathematics, by the way. It's a TV series, actual TV series called Numbers. I think it's on Netflix. No, I don't think so. It's on Netflix. Sherlock, I know. Sherlock BBC is amazing. That's one of the best series I know of. But Numbers is recommended for mathematics. Okay, I grew up watching this. I mean, in the sense I was grown. I was the age of 15. But the point is, I watched at the age of 15. So my point is somewhere then. Can you find it then? Where can you find it then? I think it's in HOQ. You know that HOQ product? I think so. It's owned by, they take it from, if I'm not wrong, Airtel TV must have it, possibly. Or Amazon Prime, one of them has it. Others, you have to download it, pirate it. Numbers. Okay, that's Numbers. Second one, I recommend these books, Ian Stewart. If you're ever planning on doing mathematical content for YouTube videos, this guy is awesome. Okay, there's a lot I pick from there for the class. I used to pick for classes in the PUC, but here I thought it's just too easy, too much time to read that book, so didn't bother. Anyways, Ian Stewart. Okay, just check it out. It's great. Yeah, Cabinet of Puzzles is also good. I know. Both are good. Okay, I have a puzzle for you. We start with a bunch of puzzles today. And the first puzzle, this is from a Russian book, the puzzle. It's an awesome one. It has nothing to do with Starbucks. Let's just say you have a cylinder, okay, tumbler, filled with whichever liquid of your choice. It could be, I don't know, orange juice, beer, urine. I don't know why they came in the same order, but anything, okay? Anything you want to fill inside it, poison, vodka, mercury, anything, okay? Fill it. Vanilla chocolate chip, yeah, fine, done. Fill it with that. Blood, okay, okay, fine. I'm scared. Anyways, something but, okay? Fill it till the brim, okay? Fill it till the brim, okay? Next part, your blood is more specific. Okay, nice, thank you. Anyways, so fill it till the brim, you vampires, and then do not drink it. You will have to empty exactly, you have to remove exactly half the amount from it. The question is, how are you going to do it? You have to remove exactly, measure half the amount, measure exactly half the amount. Okay, it's completely filled till the top. With the handle, no measuring devices are given. You have to measure exactly half of it. Cut the bottle enough. What's wrong? Like, oh, you can't. This is aluminum tatte. Our glasses, aluminum glasses. Can't break it. What instruments are given? Your eyes, your hand. You don't even have a body needed for this, so not required for the problem. With the blade, no, blade is not given. You have such limited vocabulary. I know. Double dots instead of colon. Some of the others will get it. Can you display the question on the PPT or? Nah, I just thought I'll just put a picture. I'll remember it. So the question is simple. Just try to break it. Yeah, colon, guys. Yeah, double dot colon. I get it. Drink half of it. How do you know when you reach half? Look, you don't have any measuring can or anything. How do you know when you reach exactly half? Question doesn't have enough information. There's enough information. You can solve it. That's the problem. You have to do it with minimal. So this is a puzzle. Just think about it. Yeah. Okay, there'll be markings. No, nothing. I'll come up with good. No, wait. Gut instincts. I will drink it. No. Can you repeat the question? The question is, I have a cylindrical vessel filled with liquid of your choice. Let's just say blood, and it's filled till the brim. Okay. Now, instead of drinking it, all I want is exactly half of that. How will you measure exactly half of it? I want half of it exactly, because Prajwal doesn't drink full glass of blood. He always drinks half, exact half. And I am thinking it's going to be Muralidhar's. Anyways, Just eyeball it. No, 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 no. You're not able to guess it. The thing is, you can't guess it. It's a hard puzzle. It's not so easy. Don't be hard on yourself. Just give it a shot if you can. Others, fine. Just drink when you see upper side of the glass. No, 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 no. No, you can't eyeball it and guess it that way. That doesn't work. Okay, another puzzle. Second puzzle is I have a cuboid of size 12, 8, and 6. Okay, it's a box. The question is, I want you, the thing is, let's say the sun is at infinity. So when I hold this cuboid towards the sun, I'll create a shadow on the ground. Hope you agree with that. The question is, the shadow that's created will have an area. Okay, we'll have an area. The question is, what is the largest area that can be cast by this thing, cuboid? Continue to move into the continuous funnel. No, that won't work. That won't work. Two continuous thing won't work. You guys have suggestions. Calculate the volume and find the volume which is. Calculate the volume. How are you going to calculate? No ruler, nothing. You don't have anything. You have a hand. You have your brain, which is needed. Okay, and 2 tumblers. That's all. Nothing more is given to you. Yeah. What if I give it to a friend? I'll shoot him. He's not part of the problem. I don't need him. Okay. I told you the problem has only the following. Your hand, probably to hold the glass if need be. Your brain, because you need to solve the problem. That's it.
Then you can't solve the problem because you don't have brains.
Yeah, I can't. I know. I know that. Don't you think I don't know that? That's why I'm giving it to you. Go ahead. Density itself. No, Archimedes principle. No. What about the rest of the body not needed? It'll keep you on some, I don't know, plugged into some computer like the Matrix or something like that. Will keep you functioning. Anyways, this is a game given to me. So you guys know Shrikant Pai. He handles the Olympiad sessions for mathematics in PUC. Now he gave me this puzzle. It was a fun introductory puzzle I got from him. I told you who is Shrikant Pai just now. You're sending me that question now. Okay, nice. So the thing is, he gave me this puzzle. It's an interesting puzzle. I want to see how many of you cracked this. It took me half a day. It took Quinton also half a day. We both had fun. It was fun solving it. But the question is like this. I have a circle. Okay, let's say we can't. I know. Let's say you live in a world where you have a straight edge, which means you only have a ruler. Okay, but it doesn't have markings on it. So you don't know how much is 1 centimeter or anything like that. You just have a straight edge. The problem goes something like this. There's a circle, perfect circle, and a line which constitutes the diameter. That line has been extended. Okay. A point is chosen randomly outside. Okay. You need to drop a perpendicular from that point to that line. How will you do it? You need to construct from that point to that line a perpendicular. The question is, how will you do it? No, it can't. It can't work. It's not simple. It's very hard. It's very, very hard. This problem is very hard. You need to drop the perpendicular from the point to this line. No compass. You're not allowed to use a compass. You're not allowed to use a protractor. You're only given a stick, a straight stick, which looks like a stick. Yeah, how will you join the point with the circle and stuff like that? The question is, no, you're given a scale, but it doesn't have markings on it. Tangents could be an interesting idea. Think. You could think about this. You need to draw this on a sheet of paper to get a feel for this problem. Okay, so that's the problem. You've just been given a straight edge. These are straight edge constructions. These are very famous problems. These are the beginnings of Olympiad geometry, actually. Anyways, no, it doesn't work. No, you can't do that. Join the blue dot to the other edge where the line comes out from. Where? Here. Okay, you could try some crazy things. Try that, okay. Do you know the center? You don't know the center also of the circle. That is not given to you. That information is not given. We have a pen. Yeah, you have a pen. Only a scale. The question is a circle. There is a line which forms the diameter, which has been drawn. Okay. Your point P is given to you. From that point P, you have to drop a perpendicular exactly onto that line, which means it has to form 90 degrees. The question is, how will you do it? Yeah, center doesn't help here. You don't have the center. Yeah, this line is the diameter. This line is the diameter. Yes. Think about this problem. I'm just giving it to you. It'll take your day. No protractor. You're not given a protractor. You don't have a protractor. You don't have a compass. Nothing. Yeah, take a day. Take a day. You might resolve it. It won't take you a day. If you sit and think, it won't take a day. How much is the diameter been extended? You can extend till however length you want. The extension can be however long you want. It's beyond the point at least, but you drop the perpendicular. Nah, it's not easy. Compass is not available. Protractor is not available. Only a straight edge without markings on it. You only have a stick. You can't measure that way. No, that doesn't work. You can't measure the cylinder that way. No. No. You don't have a scale to draw coordinate graph there, coordinate geometry. You don't even have a ruler to mark this thing, axis or anything. I'll get the compass from the other room. No. No shadow, nothing. You've been just given this, you have to figure it out. Okay. So figure it out. I'll leave it to you. Draw a tangent and then draw a line parallel to the point passing through it. Try it. See if it works. I don't think it'll work. It's not easy. Think. The methods are fine. Look. This teaches you a lot about the basics of okay. If you do not have a compass, how do you draw? The circle has been given to you. You don't have a compass. That's all. The circle has been given to you. Perfect circle has been given to you with the diameter. Where should you drop the perpendicular? Onto this line. Onto this line. You have to drop it onto this line. You have to draw this dotted line, basically, which is a perpendicular. Okay, that's the game. No, Rahul, not now. Okay, you may have seen this problem before. I'll give you one more problem. I have an equilateral triangle. I pick a point inside it. Okay, this is a very famous problem. You must have seen it somewhere. A point has been picked, and 3 lines are drawn to it. 3 dashed lines are drawn to it. Can you move the circle? No, you can't. So you've been given 3 dashed lines. The question is, with these angles given, 80 and 120, the angles here, this much has been given to you. The question is, these 3 lines form another triangle. Is this fine? These 3 lines, blue, red, and yellow, form another triangle. The question is, what is the angles of that triangle? What are the angles of that triangle? That's the question. I know it doesn't look equilateral, but the point is it's equilateral triangle. A point has been picked, and 3 lines, dotted lines are drawn. No star delta. 3 dotted lines are drawn. Okay, from that point. So you have to take the 3 lines, 3 dotted lines, and form a triangle out of it. You form a triangle out of it. The triangle formed will have its own angles. The question is, what is the values of those angles? A triangle has been constructed using the 3 dotted lines. You take the 3 dotted lines, get it outside of the triangle, and form your own smaller triangle using them. The question is, what is the angles of those triangles? Yeah, that's the question. Yeah, you have to rearrange the dotted lines to form a triangle. You have to rearrange, you have to pull them out, rearrange them however you want, and form a triangle. The question is, what are the angles? What all we can use? Yeah, we can use everything: mathematics, trigonometry, calculus, anything. We have all the knowledge in the world for this. No. Okay, that's another problem. The question is, while I'm at it, I have to suggest to you guys this. Have you guys played this game, Euclidia? You should have started in 8th standard, but it's too late. But anyways, if you have played it, it's good. It's fun. By the way, this would be good for a Google, the code thing, to build something like this. So I prescribe this twice a day after food, usually. Okay, before going to sleep, play one round at least of game. Okay, play at least 1 round. I know I'm promoting games here, but this is a very good game. Okay, this I've played 1 level so far. I think I don't know how well I've done. 1 second, I don't know if it's loading. I'm just checking. Why is it not loading? Okay, anyways, I'll just try to switch to this thing. The game is a geometry game. So this you'll get better at geometry eventually. Oh, clicks are not working on my. This is weird. 1 second, clicks are not working on my laptop. Okay, now it's working. So, can you show the previous puzzle? The previous puzzle is very simple. Try this one, which is that's an Olympiad level problem. Not an Olympiad level, it's an introductory problem. It's too easy. You'll get a break in some time, don't worry. By the way, I've played the games. I'm telling you, you can play this. Can you see the screen? Euclidia? Oh, I'm not sure. So this is Euclidia. There's an Android app for this. You can play it on Android also if you're interested. It's amazing. I finished one level. I mean, not one level, one game I finished in that level. There are, oh my God, how long does this take to load? They could have put a better loading screen, guys. You know, a dinosaur game or something like that. Okay. Anvita has tried it. It gets tougher as the time goes. I know. It gets tougher. The game gets tougher. That's what a game is about, right? Yeah. Good. Think about it. Yeah. I don't know why is it taking so much time to load a game. Usually game loading that takes time, but yeah. Okay, I'll give you a break. This takes time to load anyways. Yeah, that's a good recommendation. 5-minute break. Guys, go for a break. Run. I didn't say I always think about games. Games are awesome, guys. I mean, certain games. For example, Angry Birds is good for projectile motions. GTA 5, no. I think GTA Vice City I downloaded. I made the character run, open a car, killed someone. Then I was like, okay, fine, bye-bye. And that's where the game ended for me. Anyways, Candy Crush is the worst. Anyways, yeah, you can speak, yes. San Andreas, no. I didn't touch any of those. See, I was never a gamer, I told you, right? Like, not a gamer, sorry. I have played Age of Mythology and those things. Simple strategy games I've played, but not this. Have you heard the game How to Kill PD? Oh, that's nice. Sounds like a game. Yeah. I think it just takes a phone call, right? Yeah, Shashank. Took me 5 years to realize that GTA is Grand Theft Auto. Yeah, that's fine. That's good. Yeah. It took me a year though, after playing the game. So you're forgiven. Did you play Blue Whale? I have no idea. Oh, by the way, this is alpha. I have created one level. I don't know how many I can crack. Let's see how much I can crack. Till then, before I cough, I'll drink something. It took me 5 years after hearing the game. That's fine. I at least played the game and still didn't realize for 1 year. So who's the bigger noob here when it comes to games? Okay, let's construct 60 degrees. How to construct 60 degrees. I did the equilateral triangle really well. I'll play it for you guys again. I think I did the previous one very easily. Okay, here we have to construct equilateral triangle. So this is a construction. Final construction should look like this. Okay, and this is what it has to look like. I think one of the things that work for me is to use a circle, 2 circles, join them, get the
Sir, am I
intersection.
audible?
Yeah, you're audible now.
Sir, can I ask you one question?
No.
Sorry for interrupting.
No, you can't ask.
Why?
You can't.
Why?
You shouldn't torture people without brains by asking them questions.
Okay, tell me. I'm just kidding. It's funny sometimes in the classes, okay? People ask permission to enter the class. I don't know why they do that. I'm like, don't come inside. Just don't.
I guess they're not familiar to your deconstruction philosophy.
It's
You
not
know,
my philosophy.
respect your elders.
Technique. Oh, no, that's not the case, okay? People ask, like, the thing is, I've just entered. Okay, and everybody's moving around. Why do you?
Okay, shall I ask you, or else you will say your own stories?
No. Tell quickly. What's the question?
Okay, this question popped up in my mind yesterday. This question popped up in my mind yesterday. Okay,
Yeah.
fine.
Sure. Got it.
If we place an object at the focus, we get an image at infinity. You
Yes.
said this.
Yes.
Remember?
Yes.
They'll go and meet at infinity, and you will get a image there.
Yeah.
But in solving two simultaneous
Simultaneous equations.
two
Yeah.
equations, if they are parallel, they say that they don't meet at any point.
Yeah.
Why is so like that? One they meet at
I told you
infinity.
they meet at
The
infinity.
same
I told you
parallel
they
lines
meet at
don't
infinity.
meet
Right?
at infinity.
I told you
match,
they
right?
meet at infinity, right? I told you they meet at infinity, right?
But they become consistent like lines. No, they are inconsistent because
They
they
meet
don't
at
meet.
infinity. Listen to my words. They meet at infinity, I said.
Why they? Then they should become consistent lines, not inconsistent.
Listen, I didn't say they meet at 5,5. I said they meet at infinity.
Okay, they meet at infinity, comma infinity. No,
Where is
according
infinity?
to
But where is infinity?
it's somewhere on the graph. I don't know. Then it should come in.
It's not there.
Then
Where
it should
is it? Where
become
is it?
consistent.
Tell me what is the value of infinity then? If it's there on the graph, tell me
Something.
what's the value of infinity?
Something.
Look, what is infinity at the end of the day? It's a concept, right? It's a very, very far big number. So when I say infinity, comma infinity, I'm talking about a place that is really, really far. Now, that far thing could be as far as I want. Oh my God, I can hear my echo. What's wrong with your room? Anyways, so
No, they say when people die, they hear their own voice.
okay. So the thing is, the idea is that things are at infinity. So what we're talking about is that the object is, the image is formed really, really far. Now, how far depends on how much you want to consider. Like, for example, your infinity could be 1 million. My infinity could be 10 million. I'm not saying it's a fixed value. Okay, it just goes on. So what we mean by that is it meets at a point really, really far. But that point is so far that we may not be able to reach it. That's one way of going about it. Yeah, please
If they
stop
meet,
echoing.
they should come. They should become consistent lines, no, sir.
No. That's not the definition of consistent. The definition
But
of
it is.
consistent is, the definition of consistent equations is, consistent lines is that there must be a single solution.
No.
That's the idea of
consistent. Even coinciding lines are consistent.
Coinciding lines at finite distances are consistent. That's very specific. I know there's an echo in my voice. You're hearing it now. Murali says that people hear their voices when they die. So
even I heard those theories somewhere.
What?
Oh, really? I made it up just now.
Okay, fine.
Thank you, sir.
Yeah, you're welcome. Why are you telling everything twice? Have you heard of the word echo? Or should I be saying, have you heard echo? Okay. Can you, 1 second? Yeah, no, I'm poor in physics. Okay. Think of it as longitudes. They are parallel, but they meet at point. Yeah, I know. Singers, you need to discuss this thing also. What is it? Hey, by the way, you know longitudes are parallel lines, right? Shashank, we brought it up, an interesting idea. Longitudes are parallel, right? But they meet, right, at the North Pole, even though they are parallel. Hey, longitude
It's on a spherical surface.
Okay. Wait. Echo is back. Tell me. No. The thing is, see, whether they are
curved surfaces.
Yeah, on curved surfaces, things behave very differently.
That is why Euclidean geometry does not work in general.
Yeah, I know. But it works with Einstein's special relativity. Yeah, 5-sided square, I know.
Yeah, but the 5-sided square doesn't have all the diagonals equal.
No, see, it depends on the definition of square. So when I say, listen, I'll give an example. This might be an example. So how do you define something? Like, what is a square? Is it the angle that defines a square? Or is it the sides that defines a square? Or is it the area that defines a square? The question is, what is it that defines a square? Like, for example, if you ask what defines Prajwal, is it the property that is an idiot? No, that's not the property, guys. I mean, there are many other properties that define Prajwal. For example, his death probably soon. Stuff like that. You know, there could be certain things. So my point is, you need to choose what properties define things. Okay. Like, for example, how do you define an electron? What is an electron? Guys, what is an electron? How do you define it? Can you define it? You can try. You can define it. It's hard. You could go and say that it's a particle with a spin of half.
What is time?
Yeah, time is a harder definition, even biggest problem. What is mass? Worst case scenario. You could say mass is a measure of the amount of matter in the body. How do you measure massless photons then? If you have 100 photons, you still have matter, right? But there's no mass, no rest mass. So mass doesn't become the measure of matter anymore. So my point is, ultimately it boils down to a question of what is, the definitions can change. So if I tweak the definition of what a square is to me, I can get a 5-sided square if I play around. If sides are not the thing defines the square, it's the angles, then I can create a square which has 590 degrees in it. That's a 5-sided square. If my definition of a square is 90-degree angles at the corners, then I can create a 5-sided square. It's possible. You need to watch that video on your own if you're interested. What is energy? I have no idea. Okay, guys, come back. We're done with the week. I constructed a triangle as a tribute to Illuminati, and we have it here. I think I should get gotten the score. Did I get the score for constructing that? Yeah, I think I did it. Next one. We'll go for the next one. Next one, I have to draw a 60-degree angle. I have to construct the 60-degree angle. Question is how to do it. Any suggestions? Oh, I got it. If I draw a triangle, oh, there's no second point. Any idea, guys? How to construct a 60-degree angle? There's a point. I can do intersections. I have a compass, which means I can draw circles. If I draw, how to draw equilateral triangle? I have a single point. I don't have another point. Oh, I could create a point, right? Got it. I could choose a random point and create one.
Now draw a second circle with the center where.
Got it. But does it work? Does it intersect?
Yeah.
Work.
Okay, that worked.
We had this in
PD
9th grade.
PD has Alzheimer's. Please
We had this in.
don't make
9th
fun.
grade, yeah.
You guys did this? In ninth
Yeah.
grade? That's what I told you guys. Did you guys try
Your
it? That's why I asked.
concept is wrong.
No, in 9th
Oh,
grade,
you had
PD
this
was.
construction in 9th standard. Okay. Now, how to get this thing angle? I don't know.
Screw you.
Okay, fine.
That is the angle.
How do you
Remove
mark
the
it?
extra line. That is
Yeah,
4 and 4.
don't construct the triangle. Who said you to
Thank you,
construct the
thank you,
triangle?
thank you. That was stupid. One second. How do you select things in it? How do you
You
delete
are
things?
pathetic.
1 second.
Just undo it. You can't delete anything.
Most clueless person I've ever seen. Next Wikipedia page will be
No, you should. You haven't met
world's
Murali.
most clueless
You
person in
haven't-
the world. Prajwal
haven't met-
D'Souza.
You haven't met Murali. 1 second. It doesn't work, guys. Try it on. It's a chaos thing here.
No, you are chaos.
Now I'm doubting you even have Parkinson's. Your
I
hand
could
is
be worse,
shaking
right?
terribly.
Yeah, it is shaking. Oh my god.
You
it
know
could be worse
what?
than that.
If you don't go out of the class right now, your death is not far.
Nice. Good for you. The organic chemist has spoken finally. Nice. Okay. Good for you. Okay, 1 second. Yeah. The thing is, I need to sleep after this class somehow. Oh no, I have a meeting. Okay, we'll deal with this soon. Okay, finish it off. Let's do this. I think you guys are done. Play the game. I am not a best guide for this game, as you saw, as the best demo which you ever got about this game. How to do the third level? I have no idea. Just give it a shot. There are 9,089 messages. Out of them, about 40 messages came today. And I replied to about 30 of them, 35 of them. Mm-hmm.
3 cheers for PD.
Yeah, 3 cheers. I know. Guys, hip hip hooray. Okay, done. I'm done. One is enough. Anyways, guys, listen to this. The next problem. Okay, that was done. I don't think you guys saw it. Now, how many of you know about coffin problems? If you're interested, look into this. I just want to suggest.
Coffin dance?
No. Nothing to do with coffin dance. So what used to happen was back in the Russia in the 1960s, they had this issue. The issue was Russians had one issue. The issue was these Jewish students who were really smart were getting into the top universities. And the problem was they didn't like Jewish people, Russians. I mean, Russians didn't like, not Russians, people, not Russians. It's just that the authorities didn't like them. Okay. So what they used to do was, so the thing is the top heads came to the top IMO or this Olympiad champions and told them, we need your help. The help was something like this. You need to come up with some problems, math problems, which look very difficult, but have a high school level solution. Like for example, it could look like a very tough calculus problem, but it'll have a very simple solutions which even an 8th standard student could get problem, let's say. Okay. So they were done for a reason. Why they were done? Why they had to be easy? Because what they did was, whenever they came to the exam admissions, the Jewish students, they took one of these problems and gave it to the student in the Viva. The reason why they did that specifically is because if the students complain that you're discriminating, you can say, look, it was an easy problem. There was a solution. You are stupid. And people collected these problems over the years. And these were IMO related problems. And these happen to be today, there are about 40 of them which have been collected. I know it's wicked, but they were collected and these are currently called the coffin problems. You need to look it up. They're amazing, each of them, one after the other. They look very advanced, but have a beautiful solution at the end of the day. Yeah. No, I've not heard of the name though, Vivek. Yeah. So look it up if you're interested. I can open them for you. I'll just show you a glimpse of, no, don't want, it's not linked. So anyways, just check it out on your own if you're interested. I just wanted to introduce you. I actually used to put them in my DPPs in PUC, but they were not easy. Okay. Just want to talk about something. You know what the topic is by looking at one image, probably a little bit. Yeah, sure, Vivek. Have you studied similar triangles before this? Before you throw tomatoes and everything, I just need to ask.
Which is the easiest way to kill you?
Wait, or their helpline number will really help. Help you, not me. I'll be in quarantine. Okay. Okay, guys. How many of you studied on a serious note?
I think it was done in 8th, probably 9th also CFA.
Okay, how many? Yeah. No. I think in 9th you were done congruences, not similar. I don't think so. Was it similar? I'm skeptical. 9th it was okay. 8th it was congruences, if I'm not wrong. Congruences. Yeah. Okay. For how many of you it was not done? Tell me. Oh, Dinesh sir taught it. He must have taught it. Okay. Anyways. Okay. Tell me, how many of you do not know similar triangles here? I need a vote. I just need a count so that I can adjust the pace accordingly. Just send me once, it's enough. I know. Okay, I'm assuming there is a bunch of you. I saw some of your messages. Okay, kind of yes. How many of you studied and forgot? That's important also. That there's a bigger number. I bet there's a bigger number. Some of you studied and forgot. Okay. That's roughly
But it's
about.
too easy to forget.
Yeah, it's easy to forget. I know. So, okay. I want to start with similar triangles. This is the introduction. What is special about this picture? Can anyone tell me? Don't tell me your kids. No, they're not. What else?
I don't know what to call them. Pentuples.
They're similar. Okay, they're similar. Yeah.
Quintuplets, quintu, not pentu.
Quintuplets. Okay. Now these are not quintuplets. They're actually quadruplets. The brother is not part of it, sadly. Okay. The sisters are quadruplets, and they're identical quadruplets. Not even quadruplets. They're identical. They're all identical. You know, identical twins, right? It's like that. It isn't said that the chance of you ever having in your life a twin, or you meeting like knowing somebody a twin, is 1 in 500. So it's not a big number, a small number, because you actually I bet at least you met at least a pair of identical twins in your life. It's probably true. So it's 1 in 500. But the chance of you finding quadruplets is 1 in 1 crore. We calculated this during triplets is possible. Identical triplets is also possible. I know 4 sets, but 1 pair of identical twins. Yeah, 4 sets of twins, but chances you have finding someone with 4 identical, that's rare. That's very rare, and that's 1 in 1 crore. I mean, in India, it's possible multiple times because of our population, but you get the point. It's 1 in 1 crore. We calculated the probability in second phase. It was interesting, but it's there. There's a chance that everybody gets a quadruplet. Yeah, that's also possible. I'm not saying that's not possible. I'm saying it's possible that all of you could have quadruplets in the future. But the chance of that is very, very low. Okay, that could be as low as 0.000001, even very small, 1 in I don't know what. Okay. I don't know, Shashank. Let's see. Anyways, okay, on similarity triangle, similarity. So what is it that you look for when you say they are similar? Tell me. What is it that you look for? Tell me quickly. I'm doing the introduction in a different way from what you've been taught for similar triangles. I'm trying a different approach for this. It's like not exactly different, but slightly different. Oh, equal angles and proportionates. Yeah, so you look for proportions, right? So for example, you must have heard the saying, like father, like son. You know, if they appear the similar, what is it the features that you're looking for exactly? You're probably looking for angles and you're looking for ratios. Agree with me on this? I'll come to the lesson name later, as we're not done yet. Yeah. So basically you look for features. So you say, okay, some features are similar. And I think most of the time the features when we say similar are about size and angles, basically the angle preservation. We care about angle preservation. Now, I have a question. Are these two triangles similar? Look at those triangles and tell me, what did I do? No, I'm not planning. Okay, tell me. Okay, I have a question. Are they similar? Are they similar? Yes or no? First thing, are they similar? Yeah, they look similar. To feel that what they're similar, what do you think I did? What and all stupid things do you think I did? Some of you think rotated and moved. Yeah, I moved it. That's the first thing. Okay, look at this one. Is it similar? Look at the bottom one. Is it similar? Yeah. What are the things that I did to it? Tell me. They're similar. Yes. What are the things I did to it? I shrunk its size. Then I moved it. 2 things I did: movement and shrinking. Okay. What about this image? What and all I've done to it? Look, rotated about a point. Okay, I think so. That's what you guys meant. Shrunk. Okay, I've probably shrunk its size or changed the scale. Yeah. So movement, I must have moved the picture. Must have. But do you see the dog's size remains the same? Like it's similar. The pictures are still similar. They are not changed. That's my point. That's my point. Yeah, got it, guys. It's similar still. Agree with me on this. So my point is, what is similarity? What do we mean by similarity in geometry? That's the question. What do you mean by congruence? Tell me in the first place. What is congruence? Tell me. When do you say 2 things are congruent? What does it mean? Yeah, they're the same. They're the same, but careful. It's not the same. They are not the same. What do you mean by same? Tell me. What do you? I could have used similarity, right? If the same, similar. What do you mean by same? Same area, same ratios, same sides, same perimeter, same Xerox copy. You guys forgot one thing. Okay, I have a question. Are these two congruent? I'm going to put a circle around them. Are these two congruent? Careful. Yeah, they're congruent. But are they the same thing? Are they on top of each other? No, right? Okay, you got the logic. They have been moved. The location matters. Okay, they have been moved from their positions. They're congruent. They're congruent. I agree with that. So congruence, the important property I want to make is, look, listen up. My point is very simple. We say two shapes are congruent. Yeah, this is basic definition. I'm actually teaching what's called isometries. Okay, a concept called isometries. So it's not just a different namakarana. Okay, the point is I want to make is, what happened, tell me in this case? You know that this image was zoomed. What is the method? You've done this in PowerPoint, right? Or you've pulled that slider to resize the image. You've done that in your life. Yeah. Now the point is that I'm trying to make is I could have done two things to change the scale. I could have rotated it. I could have stretched it. So which are the legal things that I can do to preserve similarity? To keep a shape appear similar, what are the things that I can legally do? What are the things that I can do to an image and still maintain its, preserve its similarity? I can dilate it. There's the same dog from the. I can rotate it. Proportionately scale. That's very, very important. Okay, you need to scale it proportionately. I can spin it around. That's rotation, shrinking. Also, there's one more thing. What about reflection, guys? If I reflect this image, don't you think it'll appear the same still? Yeah, it's not just that. I can even move it around. It'll appear the same. So I have three things. So one thing I got to add, I got to tell you. If you look at all these images, I have a question. Are they similar? Are these three similar? Yeah, mirror them. Yeah, mirror would be better. Mirror them. Plane mirror them specifically. Yeah, it is Shashank. Tell me, are they this? Okay, are they similar triangles? Tell me, all the three. Are they similar? Okay. So the point is that red triangle similar to the bottom one? Yeah. What about the next new one? The last one, which I put there. Is it similar? Yeah, it is similar. But the point is, the triangles can be similar, but you couldn't be able to see them whether they're actually similar. It's not so easy to observe them and figure out. When you think about it, this triangle is somewhere else hidden in this geometrical figure, but they both are similar. This triangle and this triangle both are similar. It's not obvious because I must have rotated them and moved them around so much. I must have reflected them and done some crazy things. CPST. What is CPST? I can get that. Common S something. Yeah. So my point is similar triangles are preserved under, listen to this carefully, translation, rotation, uniform stretching. This is important. Corresponding causes of similar triangles. Yeah, I get it. Uniform stretching or I'm not yet done. Or I need to add one more thing. I forgot. Reflection. But reflection is taken care of under this thing, which is that uniform stretching, because you multiply by -1, it uniformly stretches. So the point I'm trying to make is, look, this is my triangle. This has been moved. It's been translated. Okay, this triangle is still the same. I've rotated the triangle. The triangle is still the same. They're similar. What about this? I've stretched it. The only operation that's not allowed for congruence of triangles is stretching. That's the only limitation. All the other moves are legal. You can use any other move. And to be honest, all of geometry is just boils down to these things. I don't know whether you realize this so far, but every time you did geometrical things, the constructions, whatever you did, You were actually doing one of these operations. You were doing one of these actions without your knowledge. Okay. And this is usually not taught in NCERT because this is the beginning of Olympiad stuff, usually in mathematics, Olympiad geometry. Because usually the concept is not given because a lot of interesting ideas come later called homotopy and many other things. Okay. Yeah, that's what coordinate transfer is. In fact, it's there in 10th standard, this thing, NCERT. Is it there? Translation and rotations part? I'm not sure. I don't think so. I'm not sure. Okay. Anyways, this is a combination of all three. You do all of them and then finally get the structure. Okay. So we say, you guys know this, right? We say two triangles are similar when tell me. Angles are equal. Yeah, angles should be equal. I think you guys have done with this. Angles should be equal. And the Murali is going to jump. He's going to kill himself after some time. Murali solved that problem with the circle. No, that's why I gave it, guys. You know why I gave that problem? The puzzles, 3 of them, for a reason. I know there was a chance that you might jump out of the window, some of you guys. So at least if a puzzle is there, I knew that something wouldn't happen. So yeah. What about linear transformations? Yeah, that's my point. Whole of linear transformations is about that. Okay. And that has some serious consequences in physics. Serious consequences in physics. Okay. The fact that only certain dilations are possible and stuff like that. Okay. Anyways, you guys know about this. Can I get a yes or no on this? The angles are equal. Okay. I felt like Murali was wearing a GoPro earlier and shaking his head. Anyways, yeah, you guys know this. Can I get a yes or no? I just need to make sure I don't drag it. No, Murali, you don't shake the camera. It's not a GoPro. Okay, yeah. Is this fine? Can I get a yes or no on this? The angle, the sides have to be proportional. So when you divide the sides, corresponding sides, they have to be same. Should give you the same value. Yeah, you please do that. Yeah. Repeat. Okay. The idea is that you need to take the corresponding sides, that is 8 and I don't know, in this case 4. If you divide them, you get 2. Okay. Turns out the sides are proportional. They are multiplied by some constant. So for example, the side 3, which was 3, now it has been multiplied by 6. It's not obvious. Okay. And the angles are equal. All the angles are equal. And then we say two triangles are similar. And this is a symbol for similarity. Is this fine? Yeah. Okay. With that being said, I could not find material on this, so I thought I will play you Krista King's video, and she used to do online this thing. I used to watch some of her videos back in the day. I don't know if it's going to load, but let's give it a shot. 1 second. Done, Anish. I repeated. Okay. Is it going to load? Oh, this game, which I suck at. 1 second. Why is my internet? What? I gave problems. Yeah, I know. You would never feel thought. Okay, I'll try. I don't know. This video is not loading for some reason. What is that sound? Okay, Murali. Okay. Wait, I'll mute you. Ta-da. Murali, you've been given a suggestion, learn organic chemistry. Okay, this video is not loading. Chuck it. You know what? Let's do something crazier. You guys know about the postulates, SSS postulates and all that stuff. Do not kill yourselves. Just hear me out. Yeah. The point is you don't have to compare every property to say two triangles are similar. All you got to know is few things. Okay. Okay. You are allowed to use find midpoints. Yeah, no. Oh no, you are not allowed to use midpoints. Find midpoints in that problem. Oh my God. Okay, listen up. We'll do something. Wait for you guys. Okay. So what I did yesterday is a little different. So I'll share it with you guys. 1 second. Why am I asked? Why is it popping up like this? Okay, the thing is, yeah, you guys know this one? Just asking. This physics video on what is it? The Peer puzzle. You must have heard about this. It's a famous one. Somebody did wet their pants. Okay, one second. I will turn on. Yeah. Do you remember this? I don't know whether you guys know. There's a Peer solution where you have this situation where, yeah, I did this in a few optics. Please check it out on your own. It has similar triangles in it. So just wanted to mention it. Now, there is this interesting thing called infinite geometric series. You guys know geometric series? 1 plus half plus 1. There's a beautiful geometric series proof I found. So I just wanted to show it to you guys. This is an interesting one. Hope this internet loads. Yeah. How many of you hate? Oh, some of you hate this series. It's not 3Blue1Brown. It's not by 3Blue1Brown. This video is not by 3Blue1Brown. It's somebody who uses 3Blue1Brown's code and creates these videos. Okay, similar code. Manim. He uses the Manim engine. Why is my internet acting this way? Yeah. Can you guys hear? Can you guys see? Once again, I missed half of your messages, guys. Okay, I'll play the video. Can you guys see this? Can you guys see the video? Can I play it? Yeah. A square was drawn. So we are trying to find the sum of R naught. R naught is 1. R to the power 0 is 1. 1 plus R to the power 1 plus R square plus R cube plus R to the power 4 and so on. Okay, that's the sum of the geometric series, right? 1 plus 1 half square and so on. Yeah. Now, look at the construction. A line is drawn exactly up to that point, and then so triangle is constructed. Okay. And this implies this is R and this is 1 minus R. So these other lines, you can't measure anything. Using similar triangles, 1 by s, s by 1 should be equal to, because both the triangles are similar, the top one and the bottom one. You've seen that formula, right? 1 by 1 minus r. If it starts from a is 1. You've seen this? Yeah, it relies on a simple proof, guys. It's a beautiful proof, just based on why do some channels? I don't know. I've kept the volume to the reduction, but the idea is it's a beautiful proof. It's just based on that there is some similar triangles involved here. Okay, towards the end, it's not obvious. It's not very obvious, but it's just there. S is the sum. S is the sum of all the sides. So s by that 1, the side is 1 because r to the power 0, and the what is that color? Okay, that's red, reddish orange, whatever that color is. Yeah, it's 1 by that 1 minus r. So it's a simple proof, but it's based on that. You can check out the other proofs in this video on your own if you're interested. Yeah. Okay, one of the things I wanted to talk about, since your brains are roasted, I wanted to speak about Pythagoras, but you guys know there are many proofs of Pythagoras, right? Yeah, you can draw tangents. You can draw tangents. That's allowed. You can draw tangents. You know there are multiple proofs of Pythagoras, right? There are many, in fact. Can we draw tangents with a straight edge? Yes, you can. You can. But did you guys know that Pythagoras was afraid of the beams? I mean, he was not afraid of the beams. He was. It is said that is what got him killed. He was not afraid of the beams. He thought beams were sacred. He worshipped them. He thought that the souls of the people are in the beams. Okay. So since Pythagoras believed this, it is a story that when Pythagoras was chased by his enemies to kill him, he comes across a bean field and he did not want to run over the bean field. So he stopped there and they killed him because he thought he'll trample the beans and He thought they were alive and stuff like that. Yeah. R in the what? I didn't get. Yeah, the bean field. You know beans, right? Beans. What is that thing called in Kannada? I don't know. Beans. What are they called in? I don't know. Beans, guys. What are they called? I don't know. We call peas. Yeah, can we draw parallel lines along the straight edge? You can try, but to draw parallel lines, how will you draw? Can you create a parallel line with just a ruler? You don't have any measuring equipment, right? For angles, nothing. Yeah. Beans are beans only. Yeah, I think so. If people borrowed the word as it is from English, should have had some word. A straight edge is like a ruler. Yeah, but the problem is, Hurlikai. Is it Harlikai or Hurlikai? I don't know. Anyways, I don't know how to pronounce it. Anyways, it's fine. Yeah, this is a problem I give every year in trigonometry, but I thought I'll give it here, guys. This is a challenge problem. You need to find x. You must have seen this problem somewhere. It's a very, very famous problem, but very hard. Okay, the idea is there's a triangle with the angles given 30 and 50 and 60 and 20. The point is you need to find x. You need to find x, the value of x. The construction is done like this. This line FE is not parallel. That's the important detail you need to know. FE is not parallel. Okay, and I used to solve this every year using trigonometry, but yeah. It's called Havare Kai. Okay, fine. Beans Havare Kai. Okay. Anyways, yeah, it is considered the easiest and the hardest problem in geometry. Why did they kill Pythagoras? I don't know. They had the schools where they were trying to defend knowledge. I don't know what and all they were defending. People thought, the thing is, these people, Greek people, had schools, just like Indians had people. Indians had schools of thought. Hope you know about the Sankhya school of whatever. There were many schools. So the thing is, they had these, they used to protect knowledge, which means they would not give it around, just like that. If they discovered a theorem, they would keep it secret. Pythagoras theorem, everybody knew. But if they discovered a new theorem out of it, they would keep it a secret. In fact, it is said that all of the works of Pythagoras have been burned down. Pythagorean school have been burned down. We don't know what new theorems they discovered or anything they did. They kept it sacred. If a straight line edge is like a ruler, because then, okay, straight edge is like a ruler, but it doesn't have markings on it. So for the equilateral problem, I think the diagram can't be drawn. Think. I don't know, maybe. Anybody interested can solve this. This is a puzzle which I had. I had some problems, but before that, I just want to speak about this. I know most of you know similar triangles, so I really have no idea. I know what I'm going to approach it in a different angle in the next class. Let you guys know. It's going to be approached. So since I was teaching about, so remove this, listen to this. I'm not finished similar triangles. The idea is, listen, there were some additional problems I wanted to do. I'll come to this later. Let's just say you have, okay, I think I told you, right? The whole point of similar triangles is to say that similarity is preserved under any of these transformations. You can stretch the plane, you can bend the plane, you can do all of this. Similarity is preserved. A person's face does not change if you scale evenly. Okay. Now, I have sent a message yesterday to one of you, but still I'm just going to discuss this. The idea that I cared about is, wait. What I care about is, you know, in cricket matches, they estimate distances, right? The sixes and whatnot they do. I mean, at least I told you. No, wait. Yeah, not crop. I'll come to it. The idea is like for example, do you agree if this piece, let's say this person's height was same as this person's height, we could have compared them directly, right? They're similar. Agree with me on this? See, the point is, how is this change? How is this person's height different? Even if they are same height, do you agree they appear of different distances? The face is no different maybe, but then they appear of different distances. Look at the shadow of this thing. It's different from the wickets itself. Okay, these things appear different depending on how we look at them, because we humans have this weird way of looking at objects. Okay, we don't look at it as they are, the size. Was that match between England and I have no idea. But the point is not that. Irrespective of whether you watch cricket or not, I hope you agree with this part. The perspective matters. What we don't look at the world and see same sizes of things. Depending on where things are placed, that also matters a little bit. Hope you agree with that. Agree with me on this? Yeah. Like for example, this image or distance, but depending on the placement, you can appear as if everybody is standing next to each other. So my point is, if things are similar, we can still compare. Like for example, if you look at this image, that triangle, is it similar to this one? I have a question. Are those two triangles similar? I'm asking you on this page, on this photograph that's been taken, are those two triangles similar? In this photograph. I'm not saying those tiles on the ground. In this photograph, are they similar? It is similar looking, but do you think the angles are preserved? Do you think this angle is equal to this angle? Do you think this angle is exactly vertical opposite and same angle? Do you think even the side lengths are proportionately increased of the triangles? Yeah, if you include the perspective, maybe. Yes, Murali finally understand the difference. Good. Okay, so Murali says there's a difference between observation and measurement. Yes, under measurement, yes, but not under observation. Yes. So the thing is, no, you are not allowed to construct angles. You can't. How will you construct an angle? So anyways, going ahead. So these two are not similar, but you know they're warped under this thing. What about the lines? Are they warped? Are they the same? No, they're not the same. But if I were to stretch an image, think about this. If I were to stretch an image, let's say I have, wait, I'll go to a different page. What about this green line? Are they stretched? Are they scaled the same amount? This green line and this orange line. They're not, right? Exactly. When you think about it, they're not, if you looked at it before. So my point I want to make is very simple. Let's say I have a scale like this. Let's say I have a scale which goes from here to here. This is AB. Okay. And there is a midpoint, M. Somebody comes along and stretches this line exactly to become double the length. Okay, this much. Okay, B and A like this. And this is a new midpoint. I have a question for you. If I told you that this distance is 2 and this distance is 2 and this distance is 4, how much is this distance? You guys know it instantly, right? Yeah, you would measure the ratios. Based on just ratios, you can estimate. Why can you use the ratios? Tell me. Why can you use the ratios? 2 by 2. That is, you're using basically AM by AB should be equal to, on the other side, or I'll call it A dash M dash B dash. A dash M dash A dash B dash. Agree with this? Can I get a yes on this? Clear? Yeah. So you would estimate like this. Now, reason why you can estimate this is because you have knowledge that this image has only been stretched. Agree with me on this? The image has just been stretched. That's the only knowledge you have. Or, in other words, you know that it's been scaled. The point I'm trying to make is, the reason why you can apply these formulas is because they are similar. But you do not have that luxury in this diagram. You do not have that luxury in this diagram. When you look at this, these two are not similar. You can't estimate distances just like that. You can't play that game. Okay, you can't play that game. For example, you can't say the sides are proportional and play that game anymore. Proportionality can't be a winner here. Okay, you can't take these two lines and then estimate their values and then tell, okay, the number of pixels on the screen is how many pixels on the screen? Tell me. 10 pixels, 100 pixels, probably 100 pixels. And this is, let's say, 200 pixels. And if you know this distance to be 1 meter, you can't say this is going to be 2 meters. How much? Okay, tell me, can you say, do you think this will be 2 meters? If this is 1 meter and this is 100 pixels and this is 2 meters, 200 pixels in my screen, do you think this will be 2 meters? Will it be larger than 2 meters or less than 2 meters? Tell me, is it greater than 2 meters or less than 2 meters? It will be longer. It will be longer or less than. Tell me. think. It'll be actually less than, guys, because you're looking at it from a closer point. It appears as if it's longer. If you get an object very close, it'll appear bigger, right, to your eyes. These both lines could be of the same size. Got the logic, right? Both the lines could be of same size. So the question now comes along, how do you deal with situations like this? How do you deal with what is it that remains constant? Like for example, in this case, you know that in this case that ratios remains constant. So you can play around with the ratios, and that doesn't work. So mathematicians came up with a smart thing, and it's popularly called the cross ratio. Okay, it's popularly called the cross ratio. The interesting thing about this value is it's calculated, and the mathematicians discovered it early on. This value remains constant no matter how you tilt the plane, however you observe this. Yeah, some of you might know about this. Famous. Like for example, you know about this perspective illusion, right? You do realize that she's closer than him comparatively in this picture. She appears bigger to you. But the tiles have been adjusted in such a way to make it seem for the camera as if these tiles are, what we say, the lighting has been adjusted properly, everything has been adjusted so that you feel that these tiles are actually warped. This person is really far. Look at actual images. Okay, I don't know whether you know about this. It's a famous illusion. The reason why I brought it up is, I won't discuss the shadows part, but cross ratio, there's an interesting video on this. Yeah, you don't understand who is big or small. Yeah, the cross ratio is this thing. Yeah, 1 second, I'll show you this. Okay, this is a famous episode by Number 5 where they use this. Yeah, I know. Can you guys see
I've been thinking about the world.
I'm just worried. Yeah. So look at the interesting thing it does. I'll just jump over to the end. Okay. I'll be very fast here because this takes a lot of time.
Cup allowed Brady. And then I was reminded of this really incredible goal that just turned a little bit over 20 years old. And it was a goal that Roberto Carlos from the Brazil national team scored on France in preparation for the World Cup 20 years ago.
But listen to this. So what he did was, this is a thing that's remained constant in perspective. So 1 second, come to this. Let him play it. Come on.
You might think that that should be equal to 4.5.
He took the photograph of the goal kick. So they're trying to estimate, they're trying to estimate how far was this footballer, Roberto, from the goal post when he made that shot. That's the question they're trying to figure out. Is this fine? Fine with this? They're trying to estimate how far he was actually. Yeah. The problem is, how can you estimate just based on a photograph? But the question is how to calculate is just using a photograph. Now the problem is, if you look at it, if you draw a line to the goal post, isn't this difficult? Yeah, it is difficult, but observe what you'll do. So if you look at it here, this distance, 1 second, this distance is 4.5 on the paper. Distance is 4.5. This distance is 7.3. Okay, on the paper, if you measure it using a ruler. Okay. Now observe this.
Divided by 7.3. And then you could use that equation to solve x, except it doesn't. and why doesn't it make sense? Because if
before that,
divided by
you know the distance from the goal post, right? Usually where the lines are drawn, there are fixed measurements. You know those measurements, right? Yeah, you know the measurements. What are the values? You have an idea. The inner this thing is
actually drawing a little picture here.
They're in feet, okay? I'm really sorry.
Keep that in mind because
the measurements are in feet. I think so.
Going to be important. Parallel lines like this one and this one, they're parallel.
This distance is 16.5. This distance is 5.5. If you find out x, you're done, right? Agree with me on this? If you find x, you're done. Or if you find x, you can get the distance. That's all we care about. But the problem is, because of the perspective change, the ratios don't work. So if I measure this length to be 7 and the other length to be, let's say, 4 or something, I can't take ratios and play around with this game. I know the video lag once I'm playing it.
Draw two lines that cross them, like this one and this one. Then, if I measure this distance, let's say I call it A, and this distance is B, and if I measure this distance A prime, and this distance B prime, and as long as these lines are parallel, so I'm going to draw this here to signify that these lines are parallel, then I'm going to get that A over B is equal to A prime over B prime.
For this case,
and so it feels like
lines, you can do this, right? Thales theorem. Yeah, this is Thales theorem. A by B is equal to A dash by B dash. It should be obvious.
If I want to find x and this, then I might be able to relate it over here. And the good thing is that these distances I can try to measure in this
so
picture.
what he's going to do
So I'm
is
going to
he's
try to
gonna
do
take
that.
those distances and
I'm
he's
going
going
to
to
try
measure
to
it
say,
from the
okay, well, let's mark these
So for
points over
example,
here.
here he's measuring.
And I
from
can
the
actually
picture.
measure these
So in
things.
picture,
So let me
he observes.
go ahead and do that. This is about 7.3 long, 7.3 centimeters. And this is about 4.5 centimeters. So then you might think that 16.5 divided by x, since it's equal to this distance divided by this distance, you might think that that should be equal to 4.5
You got the
divided by
logic, right?
7.3.
What he's trying to say is, hope you agree that x by 16.5 will be equal to those red color distances, right? Agree with me on this? Because they run parallel to this thing on the ground. Now the problem is he wants the ratio to calculate that. He wants the ratio between the red lines. He wants the ratio between the red lines. Agree with me on this? He wants the ratio between the red lines, but he cannot get that. So in order to do that, what he does is he compares it from the photograph. If he looks at the photograph
divided by this
which he has
distance,
taken,
you might think
he
that
can
that should be
divide
equal
this
to
7.3 by 4.5, right? Agree with me on this? He can just divide 7.3 by 4.5 from the photograph. But the problem is he can't do it. It doesn't work. Why? Because the photograph is not taken from the top. This has been captured from an angle. This 7.3 could be greater than that because you're smaller than that. You're observing from a closer distance. Agree with me on this? So that need not be exactly 7.3 pixels. Those ratios don't work that way. So mathematicians started asking a question, what is it that remains constant? What is it that remains constant when you change perspective? And they realized there was something interesting quantity. Observe this.
4.5 divided by 7. That this part over here actually looks bigger than it really is. And so what we need to figure out is how
you can't
does a change of
ratios.
perspective change measurements. And this is an interesting thing because this is a very, very classical problem in geometry. And it was first developed when artists and geometers were trying to figure out how to draw in perspective. And it's a little piece of geometry that has been somewhat forgotten, actually.
I'll tell
I think
you what
we should talk about it.
Draw some
we have a great.
Yeah.
Okay. Then the question is,
so there are two lines.
How
two lines.
does
One
this
is a green line and a red line.
Distance and this distance relate to this distance and this distance? And the trouble is, they don't. There's no relationship between them. No matter what two distances you choose here, you can choose a place to put this line so that you can get any other two distances
These two
here.
in the
There's no relation between these two numbers.
The green lines there, green gaps between the lines. Those green gaps are there, right? If you knew the ratio, you could calculate. Like for example, do you agree this green plane is tilted from the red plane? It's tilted at an angle. It's closer to you. So its distances will appear different for you from your perspective.
Numbers and these two numbers. And what the classical geometers figured out is that you actually need an additional line. So we're going to introduce an additional line. I made it very close. What they figured out is that now if you look at this number over here, so if I call this distance A, this distance B, and this distance C, and I call this little distance A, and this distance B, and this distance C, then the question is, how are these related? It turns out that the answer is this beautifully mysterious thing, where if you take 4 points, like these 4 points, and maybe I'll call these points A, B, C, and D, then there's something called the cross ratio. What you do is that you compute the distance AC, you compute the distance BD, you multiply them, and then you divide by the distance BC and the distance
I'll tell you what.
I think this is a totally weird thing to do.
The red line is a change in perspective. So that green line has come closer. So from your eye's point of view, that point out there, which you see that point there, that's your eye, you're viewing it. So when you view it, since the thing has been moved closer to you, it's appearing at some angle, the distances have been changed. A, B, and C are different. The green ABCs are different from the red ABCs, actual ABCs. Hope you guys got that part. Okay, but the question is there a relationship between those ABCs and the ABCs which is on the red line? The question is that. And what mathematicians discovered is a quantity called cross ratio. which is AC times BD, which means you take AC, that is in this case, what is AC? Tell me. It could be A plus B into C plus B plus C divided by BC, that is some other quantity, divided by this thing. When you take that value always remains constant no matter which line you took. You could get the line closer, tilt it, bend it, whatever you want to do. That value always remains constant. For some surprising reason, that value was a constant. Okay. What I mean is, I'll give an example.
Cross ratio. Why do we do this? Because it turns out that this is the quantity that is preserved by a change of perspective. So if I compute this quantity on my red points, I'm going to get the same answer as if I compute that quantity on my green.
Deep in geometry, and they're very complicated, very complicated. It requires visualization and a lot of visualization.
You can imagine, for example, one way of thinking about this is that if I look at this picture, you might think that this is a projector and this is a wall. And so if you're trying to project a movie and you angle the projector differently, then you're distorting the picture in the wall. And as you know, some things become bigger, some things become smaller. And the question is, what doesn't?
Shine a light on the projector of a wall. You know that depending on the angle of the wall, the image will appear different, right? But he says, if you were to take a ruler, whichever, let's say, whatever sheet you project it on, and calculate this value cross ratio, that value will always be a constant, no matter how the wall is. Surprisingly, for some reason. Okay, that value is always a constant.
Change. And it turns out that the one thing that doesn't change is this cross ratio. It's a very strange thing.
It's not similar to harmonic.
But that's the thing that is going to allow us to compute Roberto Carlos's goal, because this is just a change of perspective between the angle of the camera
in cricket they estimate this thing, right? When you make a shot, when somebody plays a shot, they estimate how far the six goes. They say it's 119 meters, point something meters. There are some estimations done. That's done based on certain projectile motion calculations and the camera angles and stuff like that. You must understand, if they're estimating the distance of a six to be exactly 87 meters plus or minus, let's say 10 centimeters, that's a great achievement. The problem is they're just doing it using simple cameras. Okay, the ball moves in some plane and they're using two cameras to estimate the ball's distance. My point is, the underlying math is the same, what's going on here. Okay, it's got to do with these ideas. It's just that that ball, in my perspective, what I'm looking at, will obey the same cross ratio values. Okay, what is the value? The value depends on the projection you're doing, the image which you're taking, which you're projecting. Okay, I'll tell you what I mean by that. I didn't prepare really well for this because I was just reading it yesterday a lot on this. It's not very well polished, but this is called the
angle from the sky. And so we can just compute the cross ratio. And these two pictures
there should be 4 points. You
that it should be fixed, and we'll figure out the distance.
If there are no 4 points in your calculation, you can't calculate it.
One thing you might notice, we don't have enough information now, because to compute the cross ratio, we need 4 points.
Just by taking a picture, he can estimate how far a person was from the goal post. Just by taking a picture. Yeah. So anyways, that's about it for the day. I think Shashank wants to show his solution. Tell me what's the solution for the circle thing. You guys have gotten it? You guys can take it. I'll figure this out. I'll show you something. There is a quiz today. Yes, there is a quiz today. Quiz time. When do you want it? Okay, one second. When do you guys want it? Till 10? No. 1 second. I'm deciding because I'm actually setting it up right now. It takes time. Topic for today's quiz: quadratic equations. Okay, 1 second. It'll take me a minute. Shashank, you have time till then to show your solution. Whatever it is. No, the quiz starts now. It goes on for a long time. Oh my God, why is my internet acting like this? And it's my internet. I didn't start it. It's not working. It's weird. And the fonts are weird. Something went wrong. Nah, I can't. I'll keep it till 8 if I want. I'll keep it at 8 o'clock. But I'll release it now. Fine. I think you guys can survive a quiz. No, you can't reflect it. How will you reflect it is a question. You can't reflect things.
No, but sir, actually with the ruler, you can't draw parallel lines, right?
How? How are you going to do
The
it?
edges of the ruler are parallel.
Oh, no. I'm going to give you a crooked ruler. Only with one edge being straight. You won't even get the 90-degree of the ruler. Like that, you can use the 90-degree of the ruler. Got it, right? See, if the ruler is made up of, if it's a ruler, it'll be made of rectangle, right? It's a rectangular thing. It has a 90-degree on its corners. You can take advantage of that. Okay. So, yeah, you can't use that. I'm sorry. That's why it's a challenging one. Otherwise, anybody can solve it. It's not that hard. Otherwise, how? It'll be very easy. Okay, quiz deadline is 8 o'clock. Your time till then. Good luck with it. Grade importing is on. Ta-da! Quiz is assigned. Good luck. Solve it. No, that's not there. I'm using the fact that triangles in a semicircle are right angles. Yeah, you can. That's a game. That's a game, Shashank. That's a game to play with this problem. That is a game. Okay, I have a meeting to attend at 6 o'clock. Bye-bye, guys. Yeah. Schoology or Google Classroom? Obviously, it's in Google Classroom. Why would I take it to Schoology? I can't even correct your answers if it goes wrong. Yeah, I revealed a hint.
Pretty boring life, meetings, class.
Yeah, right. I should rather die, right?
No, today, sitting in your class, I understood boredom can kill.
Yeah,
You feel
I know.
pathetic about your life.
Yeah, I know. Sadly, I don't know what to do. I feel like it, Okay, wait, yeah, I know.
No idea how to reply to that.
Which one? Looking at yeah. One more suggestion came in. Maybe looking at benzene and carbon atoms should make it interesting for you. Like, you should try that sometimes, I guess. Yeah. Meditate. Benzene.
What the hell is wrong with meditating?
No, meditating is fine. The benzene part is awesome. There's nothing wrong with meditating. I think his room will have posters of benzene rings. Yeah, probably.
Looks like your soul is keeping some secrets from your brains.
Oh, benzene rings. What else is there? Now I remembered. Wait, thank you. Wait, what was there? Come on. I said, please send them in the chat. I'm begging you. What else was there? Damn it, I can't think. There's benzene rings.
There is a notebook that I kept on art of ignoring.
Yeah, please pick it up and tear the
Oh, my
pages.
mic.
Yeah, that is well done. Okay, I appreciate that. Thank you. That is good. I'll sleep while meditating, it seems. Okay, good for you.
I have better things to do than talking to you.
There is a question for you. Murali, what do you see when you look at a football? Is it a ball or is it structure of C60? The fullerene. Thinking of a reply, think a little bit, deep more.
Yeah.
Maybe in the book there is an answer. Check in the book. It's there. Oh, no. If the solution is minus 3, write it, right? Plus 3. Anyways, I'll go. Bye-bye. Okay, see ya. I gotta go. Please send the emails. If you're not sending the emails, it will lead to problems. I'm not kidding. Okay, if there is any issue with the scores or anything, please send it by 6 o'clock. Time till then. Bye-bye.
Yeah, there is a surprise waiting for you in your mailbox.
Oh, God. Bye-bye. Yeah. Anyways, bye bye. See you guys.